2. For this first one, they were really kind of mean on this one because they didn't give these formulas for a cylinder and for a circle. But we'll see what you guys remember. It says, consider all right circular cylinders. So that's just, a cylinder is just like a can, like just think a soup can, something like that. Not a great artist, but there's your visual for that. Which the sum of the height and the circumference is 30 centimeters. What is the radius of one that has a maximum volume? So we want to optimize our volume. So we need a volume formula for a cylinder, and they didn't give it. So I'll obviously tell you if we've all forgotten, but what's the volume of a cylinder? Did anyone remember it or look it up?
2 pi r times, no, that's for the circumference. I wrote it down. Pi r squared times h.
There we go. Pi r squared is the area of the base circle. That's pi r squared, and then times the height. So pi r squared h is your volume for a cylinder. They didn't give that. That was kind of mean, I feel like. And then, yeah, you were right. 2 pi r is the circumference. That's 2 pi r. Now this says the sum, so we're going to add them together. The height and the circumference is 30. And the reason that we need that is we have to substitute one of these variables out. Now, a lot of the problems we did last class, it kind of didn't matter which variable you substituted out, but in this case, h is going to be a whole lot easier to get by itself. So I am going to get h by itself, subtract over the 2 pi r, and then that is going to get plugged in right here. So we'll have volume equals pi r squared times all of this. Now, what we want to do is derivative equals 0 because that will give us our critical points. Before I do the derivative, though, I'm just going to distribute through here so that I don't have to do a product rule. That's kind of up to you. That's like personal preference, but I'm just sort of cleaning this up before I do the derivative. So distributing through here will give me 30 pi r squared minus 2 pi squared r cubed. I get that that looks strange. It's pi times pi, so it's pi squared. Just remember that's a number. Pi is just 3.14, da 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 da, so it's just a value. All right, so now I'm going to do derivative equals 0. So this will be bringing the 2 down. That'll be 60 pi r minus, and then bringing the 3 down will be 6 pi squared r squared. And we're going to set that equal to 0 to get the critical points. So factoring this, we can take out 6, we can take out pi, and we can take out an r. So dividing that out will leave us with 10 minus, what would that be, pi r? Now setting each of these equal to 0, this first one would give you r equals 0, which is not going to work. You can't have a radius of nothing. So we're just going to work with this one. So setting this equal to 0, I'm going to add over the pi r, and then we'll divide by pi. So 10 over pi is our answer, and that was E. So that one was tough for a lot of reasons. First of all, they didn't give you the formulas for volume of a cylinder and circumference, so you had to either look those up or know those. And then you also had to do this substitution to get rid of the height there. Right, and just jump in if you have a question, guys. All right, this one, I know I'm going to need a calculator at some point because looking at these choices, I have all these decimals. So I know I'm going to need to pick up a calculator here at some point in this problem. So a rectangle with one side on the x-axis has its upper vertices, that just means these points here, on the graph of cosine, as shown above. What is the maximum area of the white rectangle? All right, so we need to get an area formula for this rectangle. Looking just at this side, this is x, and this is y. We're talking about a graph. We have x and we have y. And so on this side, that means this is also going to be x. So when I do the area of this rectangle, doing base times height, it's going to be 2x times y. And now the problem with that is I have two variables, so I need to substitute one of them out. And they told us that on this graph, y is cosine of x. So that's going to get substituted in for y. So now it is all one variable, and we can do derivative equals 0. So this is going to be a product rule. So we're going to have the first thing times derivative of the second, which will be negative sine, plus the second times derivative of the first. Derivative of 2x would just be 2. And we're going to set that equal to 0. And here's where the calculator is going to come in. I'm going to put this into y equals and calculate where it equals 0. So into y1, I'm going to write this as negative 2x. Let's put that negative out front for the coefficient. So negative 2x sine of x plus 2 cosine x. Now this touches 0 at a lot of places, but we're going to want something that's like right next to 0. It's going to be like this first place after the origin. So this is the one that we want right here. So I'm going to go to calculate. Let me move this up here. I'm going to go to calculate. So second trace, I want a 0. And that appears to be really, really close to 1. So I'm going to make my left bound 0, enter, right bound 2, enter, and guess 1, enter. And that will come up. Now, here's the tricky thing about this problem. I mean, there's a lot of difficult things about this problem, but that's one of the choices, 0.860. But we're not done yet. We want the actual area for the white rectangle. So I have to take that x value and plug it back in right here for x. Now again, the cool thing about the calculator is right now, as long as I don't do anything to mess it up in between, it has x stored as that. So I can just go back and type 2x cosine of x, and it will plug it in for me. And so there is my answer, 1.122, and so that is C. Right, so number 3, here's our function. We have an interval from 0 to 9. We want the absolute maximum value of the function occurs when x equals what? And so we're going to need our critical points. So I'm going to find the derivative. Derivative would be x squared minus 8x plus 12. And so if we factor that, we'll have x minus 2, x minus 6. We're setting this equal to 0 to get our critical points. And so our critical points are 2 and 6. Now they asked for the absolute maximum. So that's going to be our candidates test. And so these are our candidates, but what else are our candidates? Because we have other candidates that need to go in the chart too. What else is going to need to go there?
The endpoints.
Yeah, good, endpoints. So 0 and 9. So we're going to have 0, 2, 6, and 9. And those get plugged into the original function. So here's the really tedious part, because you wouldn't get a calculator for something like this. We got to fight our way through it. 0 is not bad. 0 is just going to give you -5. Let's see what we get for 2. 2 cubed is 8. So that first part will be 8/3 minus 2 squared is 4 times 4 will be 16 plus 2 times 12 will be 24 minus 5. So let's see. Negative 16 and negative 5, that'll be negative 21. Plus 24 would be 3. And if I want to change that to thirds, 3 would be 9 thirds. So I have 9 thirds plus 8 thirds. Ooh, would be 17 thirds, which would be about like what, 5 point something, 5-ish. 15 divided by 3 would be 5. So that's like 5 and a little bit. All right, plugging in 6. 6 cubed would be 216. Dividing that by 3. Let's see, 216 divided by 3 would be 72. And again, this would be a non-calculator problem. It's not kind of them, it's just the way it is. So you got to fight your way through it, all right? 6 squared is 36 times 4 would be 144 plus, where am I at now? 12 times 6 would be 72 and then minus 5. So let's see. 72 and 72 would be 144, minus 144 would be 0, so that's all gone. We're just left with negative 5. And then the last one, 9 cubed. I don't know 9 cubed off the top of my head. I'm just going to work that out. That would be, oh my gosh, I've totally lost my mind here. What is that, 729? And then we want to do a third of that. So dividing by 3 will give me, and then 3 goes into 9. 3 times 243. Gosh, I wish I could pick up a calculator. Doing all these like side problems here to work this out. Unless you can do this in your head. I've met people that basically have a calculator in their head and they can just do this. I'm not one of those people. I always have to work it out. All right, so 243 minus. All right, what was I plugging in? 9. So 9 squared is 81 times 4 be 324 plus 12 times 9 be 108 and then minus 5. So, oh gosh, let's see what this is. 108 minus 5, that'd be 103 plus 243 would be 346 minus 324 would be, what is that, 22? Is anyone double checking me on all this? Trying to do it without a calculator because that's how you'd have to do it on the exam. All right, so those are all of the results that we got out of that. They're asking for the, or actually, are they asking for the maximum or just where it happens? Absolute maximum value occurs when X is. All right, so the biggest result I got out of here was 22, and that happens when X is 9, so E. That was a lot of work for a multiple choice question. And they do put ones on the exam like that where you aren't allowed a calculator and you have to somehow figure all that out. I guess you wouldn't necessarily have to figure all these values out exactly, just know which one was the biggest or which one was the smallest if they asked for a minimum. I like to be real thorough and just figure it all out. All right, so number 4, let f be a function defined by this. What is the absolute maximum value? Now this one, they didn't give us an interval, so we're gonna have to just go with the critical points here. This is gonna be a quotient rule. So quotient rule, we're gonna start with denominator, and then derivative of the numerator would be 1 over x minus numerator, and then derivative of x is just 1. You don't have to write that if you don't want to. Over denominator squared, and we're going to set this equal to 0. I'm going to set the numerator equal to 0 and the denominator equal to 0 because critical points are where your derivative is 0 or undefined. So I'm going to do the numerator and the denominator. So the numerator, these are going to cancel. That'll just be 1 minus ln of x equals 0. And then denominator is just going to give you 0. But for this one, we're going to add over the ln of x. And then what result would that give us? What x value here would give you 1? What is x going to have to be for this?
E.
Yeah, good. That'll be e. ln and e cancel, so that's how you end up with 1. And then I'm going to make a chart for this as well. I know it's not technically a candidate's test, but I'm going to test each of these. I'm going to test 0 and e, and they have to get plugged into the original function. So when I go to plug in 0, that's not going to work because I can't have a 0 denominator. So that one doesn't exist. So it's going to have to be this one. If I plug in e, ln of e would be 1, and then my denominator would just be e. So this has to be the maximum because it's the only one that I got a result out of. And so that's 1 over e. So B for that one. All right, number 5, let g be the function given by this. K is a constant. We're going to find k, and it says g has a critical point at 2/3. Critical point means derivative equals 0. And so they're telling us the derivative at 2/3 is 0, since that's a critical point. So we're going to have to find the derivative, and that's going to be a product rule. So it will be the first thing, so x squared, derivative of e to the kx. That's going to be e to the kx. And then there's a chain rule. You have to multiply on the derivative of kx, which would be k. So I'm just going to put that out front. Plus the second thing times derivative of the first. And we are going to set this equal to 0. I would like to factor it, though, to make this look a little bit nicer. We can take an e to the kx out of both of them, and we can also take an x. So if I factor that out, I am going to be left with kx plus, what is that, 2. Now, an exponential is never going to equal 0, so I'm not going to get anything further out of this factor. Exponentials are that like swoopy shape, and they have the asymptote at 0, so it's never going to touch 0. So I'm just going to work with this factor. And again, if we plug in 2/3, that's when our derivative should be 0. So this will be 2/3 k plus 2 equals 0. And then we're just going to solve that. So subtract 2, and then multiply by 3/2 to get that to cancel. And so k is -3. All right, 6 is asking how many critical points, not what are they, just how many does it have? So how many critical points does this function have? Okay, well, again, it's derivative equals 0, and we'll see where that takes us. And again, it's a product rule. So first thing, times derivative of the second. So bring the 4 down. It's going to drop to a 3. Now, there is a chain rule here. You have to chain on the derivative of x minus 3, but that would just be 1. So you can write times 1 there if you want. This is already pretty cluttered, so I'm going to not write it, but there was a chain rule. It's just it was just 1. All right, so first derivative of the second plus second, and then derivative of the first. So bring the 5 down, it's going to drop to the 4. And then same thing, there is a chain rule, but derivative of x plus 2 would just be 1. So you can write times 1 if you want to. And we're going to set it equal to 0 because it said critical points. So let's try to factor this. I know this looks like a lot. This is the first term, and this is the second term. So we're looking for things they have in common that we could factor out. They both have some x plus 2s, and we can take 4 of them. And they both have x minus 3s, and we can take 3 of them. So that's our common not common denominator, what am I talking about? That is our factor, our greatest common factor. And I'm going to kind of scribble them out. If I take 4 of these x plus 2s, I only have 1 left there. These will be all gone. And if I take 3 of the x minus 3's, these will be all gone, and I'll only have 1 left there. So seeing what's left, I've got 4 times x plus 2, so that's 4x plus 8, plus, and then this will give me 5x minus 15. I'm not going to work any farther through it because I don't need to figure out what these values actually are, just how many I would get. And I would get 1 from this factor, 1 from this factor, and then if I combined like terms and things here, I would get 1 from this factor. So we would get 3 critical points out of that. And you could keep going and figure out what they are if you want to. I mean, I guess that one would be -2 and that one would be 3. This one you'd have to combine some stuff together, but you will get 3 of them. All right, number 7, they give us these values in a table. It says the function is continuous and differentiable. So that means all of our theorems are going to be in play here, like intermediate value theorem, mean value theorem, etc. And we are given selected values of f on this interval, which must be true. Now, we can't determine where there's a maximum or minimum because we don't know what happened in between these values. So we're not going to be able to get that. I know this is really tiny. I'm kind of frustrated with College Board with the notation that they're putting here, but this says derivative is positive and derivative is negative. Derivative being positive would mean the function was increasing. Derivative being negative means it would be decreasing. Again, we can't get that out of here because we don't know what was happening in between each of these values. So it is going to be E. This says there exists a value C somewhere on the interval where f prime of C equals 0. The reason that that will be the case is if you look at 0 and 4, they're both at 2. So if you did that slope between those 2 points, or if you thought about like connecting those points, they would connect with a flat line. So that would be a 0 slope. So E for that one. That was Rolle's theorem. And then this last one, piecewise function, we want to find K so that the function is continuous. That means we want the 2 pieces to meet up. So I'm going to set them equal. And this one was actually kind of nice. They factored it for you, and these are going to cancel. So I'm just going to set those equal and then plug in 2 for x. So if I plug in 2, that is going to give me 5.